Hello friends, today we are going to see about another latest and so interesting topic today, that is GraphDB DB in GenAI. We all know about vector database, which we have previously saw in previous video. um, this vector base is very useful in implementing more knowledge to an LLM. Like if LLM is trained on internet data, whenever you ask some question, it will answer it. If it is know about it, whenever you use that LLM model, but we asking a question uh, that was out of the box, the LLM cannot be answered because the uh, the the question we are asking, for that question the answer is not known to the LLM because it is not trained on the data, the relevant data. So we provide some external knowledge by using rack technique. Because of that external knowledge, it will answer the question. At there we mostly use vector DB. If there is an LLM, this LLM is trained on internet data. We can ask a question like what is capital of India? uh, let's let LLM be a um, chat GPT. The chat GPT is trained on internet data. We can ask question relevant to internet data, the data which present in the internet, so that it can answer it. But if you ask a question to the chatbot, the question is relevant to our business. Business means it cannot be answered. For example, uh, uh, let's take example. I am running a business. um, it can be a supermarket. I running a supermarket. So I asking the question to the LLM, what is the revenue for today? Asking to the chatbot. The chatbot will not answer that question. It can answer, but the answer was irrelevant because it did not know about how much sales that had been happened today in my supermarket, because these data are private data. Mostly the business data are uh, protected and stored in a separate database. It can be accessed by the business owners can be access it. Business owners can be access it if anyone from from the anyone from outside of the business, they cannot access it. Like that, the chat BT is trained on internet data, so that he did not know about the business related things that uh, I have been running. So if the if I want to um, if I want to get a response from a chat GPT, that response should be related to my business. I need to provide the business data business data business data to the chat GPT. So I can be fine tune this chat GPT. Chat GPT is using GPT. Right now it is using GPT 4.0 LLM model. So I retrained this I fine tune this model related to my business data. Means it takes more time. Sometimes it need to train this the chat GPT model to my business needs. It takes some time, some computational power, some storage. It can be a huge amount of um, memory storage space should be needed. So but there is an alternative solution. We can provide an external knowledge to an LLM, but the external knowledge is get from outside of the LLM. I I take this data and my business and store it in a vector database. In vector database, from this vector database, the LLM will get the information about um, my business, and whenever I asking the query, it can be answered. It can be answered. If I asking what is the sales rate, it can easily, the data are stored in this vector database. Yeah, daily sales will be is stored in vector database in numerical format. It will get that temporary knowledge from this vector database, and it will display the today's sales will be today's sales is around $15 something like that. It can be answered. So here we are using vector database. There is in this vector database, um, it will store the data by using similarity search. If for example, if we asking the query to LLM, the query is first uh, give to this vector database. Depending upon the query will search the similarity data in vector database and get that specific data only using the similarity search, and it will be given to the LLM. And this that data there is overall there is so many data is overall my business data is stored in data vector database, but depending upon the query, the data will be retrieved. The retrieved data is called as context. The context will be provided to this LLM. This LLM will um, this context it given to this LLM, and the query also given to this LLM. Depending upon this both, the LLM will answer. So this is most previously we saw. But instead of using vector database, we can use an alternate database. It is called GraphDB. It is an advanced DB. It uses the vector database uses a vector technique to store the um, language data in a numerical format uh, in a some dimension of vector it will store, but in GraphDB it will graphically store the data, and it will relay the data depending upon some relationship. Today we are going to see in depth about this GraphDB, how this will be work, and what technique uh, does it is using, and then what kind of uh, what kind of concept will be present in this GraphDB. These kind of things we are going to see today. Let's go to the agenda. Today agenda is, first we are going to see, about knowledge graph. Using this knowledge graph only, the vector database will work, and and um, and then rack technique, and overview of rack technique, and then and neo 4j neo 4j. Here the neo 4j is an graph database. We all know about MySQL and Microsoft SQL Server and Oracle. These are transactional database, and and we store this we store data in this database in a format of rows and columns. Like this, Neo 4j is a graphical database. It will store the data in a graphical format. Graphical format means each data having some relationship with another data. This database will present the data and the relationship between others. Like that, it will um, store the informations. Okay, let's move on to knowledge graph. Knowledge graph. Okay. In knowledge graph, it will uses some kind of network, that is semantic network. This semantic network is form of real world entity. That means the real world names. This semantic network will have this network. It is a network of real world entity. What entities? what is uh, what is meant by real world entities? Let let's for example, the entities will be an event. It can be an events, or it can be a situation, or it can be a concept. It can be a concept. That means um, this event, these examples, this event, situation, concept will illustrate the relation between them. In this will be, this all will be illustrate the relation between them. That means between the entity present in the network. Okay, I think you are a little bit confused. Mm, let's take a sentence. Rohit, we can move on to next page, so it can be more better. Rohit Sharma is the captain of India Indian cricket team, and we have another data also. Rishabh Pant is the keeper of Indian cricket team. Okay, this is the two data we having. So we need to uh, train this data by using this knowledge graph. Means it will be store this data in a graphical format, and their relationship. We can just see this. They can see this two sentence. There is some relationship will be there, because the Rohit Sharma and Rishabh Pant, the both are playing to Indian team, and to that Indian team there is some relationship. For example, Rohit Sharma is the captain of Indian team. This Indian team and Rohit Sharma is entity, is both entity having some relationship, is called captain. Captain. Like that, Rishabh Pant is the keeper of India cricket team. This both Indian team and Rishabh Pant are entities, and their relationship is keeper. Okay. In a knowledge graph, there are mainly three main components are there. Main components are there. The first one is node. This node, it can be anything like object. It can be any object, or place, or it can be person. Like that, this node will represent the object, place, and person. And second one is edges. Edges will give each edge there is an edge between the nodes. These edges will represent the relationship of node and edge define the relationship between the nodes, and other one is label. Label means uh, label means a name. There it can be a captain, it can be a keeper. This kind of is called as label. Okay, let's see. Let's create, by using this data, we can create a graph so that you can easily understand. There is one node. This node name is Rohit Sharma, and there is another node, Indian cricket team, and there is another node. It name as Rishabh Pant. So this Rohit Sharma have some direct relationship with this Indian cricket team. This is called as edge, and this is called as node. The um, each Rishabh Pant and Indian team and Rohit Sharma, this is a node. There is a relation between this. It is called it can be it can be labeled as a relationship between the Indian cricket team and Rohit Sharma is captain of Indian cricket team. So Rohit Sharma have a direct relationship with Indian team as a captain, and like this, Rishabh Pant have some direct relationship with Indian cricket team. The relationship is keeper, and there is also another relationship between Rohit Sharma and Rishabh Pant, but this time they both not having relationship in both direction, because this relationship is they are both teammate teammate like Rohit Sharma is captain of India. Okay, so that only we put the arrow like this. Okay, but India is captain of Rohit Sharma means it is wrong. There is only a relation from Rohit Sharma to Indian team, not like Indian team to Rohit Sharma. So it is so we put arrow like this, but here Rohit Sharma is teammate of Rishabh Pant. So in this direction we put arrow. Rishabh Pant is teammate of Rohit Sharma. So this relationship make in both direction. This this direction indication is called edges. I think you all got it. And there can be other relationship also. We just trained this data using this two sentence only. But if we add more sentences, this graph will be go further depending upon the data we provide. There is another data. Let's take Everett Kohli. Everett Kohli is had some relationship with Rohit Sharma and Rishabh Pant. This time we have take another relationship. Virat Kohli is friend of Rohit Sharma. Yeah, because we already know about they both are in the same team for a long time. So we all know about they are both are friends. So like that, Virat Kohli is friend of Rishabh Pant, and Rishabh Pant is friend of Virat Kohli. So here there is another relationship also. So if we add more data, the graph will grow further, and we can make more relationship, and depending upon the relationship, we can get a good when we asking some question, we can get a response depending upon this relationship. Like this only, this graph algorithm, the graph knowledge is working on GraphDB. This is the concept behind a low level idea behind the GraphDB. Okay, we already know about NER. I think if you all are working on NLP, you can know about NER. NER means name, entity recognition. Recognition. Okay. This is an NLP library that used in Python. It will recognize the names in a sentence. Because let's take here here Rohit Sharma is a name, but is the of these are not a name entity. So, but these all are word. So, to find the word which are entity or a name, we can use this library. We will use this library in Python in LLP. Like this only, the data is stored um, in GraphDB, and LLM will get some extra knowledge from this GraphDB and gives a response. Okay, then let's move on to the uh, overall flow. How does this graph technique is used in this graph technique is used in RAG, and how this RAG will help to an LLM. Let's see about RAG. RAG means retrieval augmental generation. This is the full form of an RAG. I think you all know about it. How does the overall RAG will work? There is an document. This document will have some information about our business, and firstly this document is split it into some chunks. Chunks means we just splitting the document into small pieces. This each pieces is called as chunk, and these chunks are then one by one. um, these chunks are just a text. We convert this text into a numerical format and we store it in a database. How does this text will converted into numeric? We already know about the embedding technique. This embedding technique, by using embedding technique, the word will be converted into sorry converted into um, converted into in a numerical format, and we store that numerical data in a vector form with some dimensions. The vector will have a dimensions. Mostly this embedding technique mostly this embedding technique can be um, mostly we use uh, some database will use back off technique, and we all know about TF-TDF and word to vec. The most of the DB uses word to vec embedded technique. This word to vec embedded technique is uses cosine similarity. Cosine similarity. Cosine similarity. We know what is cosine similarity means. It is a formula used in maths to know about the relation between the data that present in some dimensions. This cosine similarity, if we use cosine similarity in vector database, uh, it is called as similarity search. If a vector database is using cosine similarity, using this cosine similarity, the database is finding the relevant data in the database means relevant data in a database means this technique is called uh, similarity search. And after converting this uh, text into vector, each chunks is converted into numerical format and stored in a stored in a vector database, vector database, vector DB. There are so many vector DB are there. Pine Code, Cassandra, Astra, DB, and um, Fezi and ChromaDB. Um, this Pine Code, Cassandra, Pine Code, Astra, Fezi, and ChromaDB uses dense vector database. The dense vector data means is similar to the similarity search. The alternate name of dense vector search is similarity vector search. These databases are using similarity search only. Okay. So, like this, the data are converted into chunks, and this each chunks is converted into a numerical data and stored in a form of vector with a dimensions, with some dimension, and it will store in a vector database, and and the in a vector database, and you and the stored data in the vector database, the LLM will retrieve the similarity data that relevant to the query asked by the user, and the LLM will answer. This overall uh, um, this overall technique is used to give some external knowledge to an LLM to get a response for our need. Okay, I think you all are understood. We can see more further on next days. Okay. mm, and then okay, yeah, let's see an example how this GraphDB is working. Let's take an example. We searching a name in Google. Depending upon the name, the Google will show the content, but not only that specific content. It will show the similar data that present in the internet. uh, let's I will search I will open my Chrome, and in Google I will Google about Sundar Pichai. Okay. I just in backend this Google search engine using some graphical graph technique to search the Sundar Pichai and the relevant data to Sundar Pichai also. Okay, you can see when I search about Sundar Pichai, the Google will show the answer. Who is Sundar Pichai? The most relevant data will be shown first. Okay, it show details about Sundar Pichai, but if we could scroll down, we can see that not only it show about Sundar Pichai, it's also show about Narendra Modi, Anjali Pichai, Larry Page, and Satya Narayana Murthy. I just searched for one thing, that is Sundar Pichai, but here some another persons also showing in the search, because we already know about Sundar Pichai. Pichai is an Indian. So there is some relation between Sundar Pichai and India, and there is also some relationship between Narendra Modi and Sundar Pichai. Not Sundar Pichai, India. So the both are some relationship. That relationship is both are Indians, and there is another Anjali Pichai. There is some relationship between Sundar Pichai and Anjali Pichai because they are couples. Anjali Pichai is wife of Sundar Pichai. So that I just searched about Sundar Pichai. It also show about some detail of Anjali Pichai. And there is also Larry Page. We already know about Larry Page. Larry Page is founder of Google, and Sundar is CEO of Google. Hmm. And we also know about Satya Narayana Murthy. Hmm. Because he also already we know about Satya Narayana Murthy is CEO of Microsoft, and there is some relationship between Microsoft and Google. They are both are uh, they both are a product company. They're producing software. They both are a top IT company in the world. And the Sundar Pichai also an Indian. Satya Nadella is also an Indian. So like um, this information, the information of Sundar Pichai and Satyamurthy are present in the data stored in a database. Whenever asking the question, it the algorithm will take the relevant data in that database and also the relevant data also. So like this only, um, use like this only. This Google search engine uses graph technique to answer our queries. I think this last thing, it by saying this last thing which I have present, you can easily understand how does this GraphDB work. You can also search any other name. You can get some relevant data according to the query. I think today that's all. We can see more about generative AI in upcoming classes. Thank you. Thank you.